Let's suppose a body has been found. One of the most important pieces of information to get is to find out how long that person has been dead. This is of great importance for reconstruction of the sequence of events that led up to the incident. And if this is a murder, then of course you want to compare that time of death to the known movements of whoever the suspects are. Well, what we're going to do is look at some of the different techniques that can be used, starting off with bodies that have died very, very recently. So what happens at death? Well, the first thing, of course, is the body goes limp. That's because your muscles are under tension when you're alive, because your brain is telling them to do so. When your brain stops telling your muscles to be tense, they go limp. And then all the biochemical machinery that's going on inside you and is keeping you alive grinds to a halt. And one of the things that that machinery is doing is maintaining your body temperature. You are burning fuel that you get from your food in order to maintain your temperature at the correct level. That comes to a stop, and that means that your body will start to cool down. This phenomenon is called algor mortis, and is one of the most important methods for estimating time of death. However, these estimates should always be done by someone who is experienced in this kind of work, because the rate at which your body cools can be affected by all sorts of different factors. One factor is the size of the body. A thin person is going to cool down much faster than a fat person, and that is simply a reflection of the surface area to volume ratio. The location in which the body is placed is going to make a big difference. If it's out on a hillside with the wind blowing over it, it's going to be cooling down faster than if it's locked in a trunk or a bag. The amount of clothing will obviously affect it. A naked body or a body wearing just t-shirt and shorts is going to cool faster than one that's buttoned up in a thick, heavy winter overcoat. And of course, the weather will have an effect. If the body is out in cold weather with a cold wind blowing and the rain falling, it will cool down faster than on a hot day in the sunshine. In addition to these environmental factors, it's also important to make sure you measure the correct body temperature. Obviously, the skin will feel cool after a relatively short time, again, depending on environmental factors. But even when we consider internal organs for measuring the temperature, we have to get it right. The brain, for instance, it has very little insulation from the outside elements, which means that the brain will cool down distinctly faster than internal organs. And it's those internal organs which should be measured, because they will give you the most representative temperature. And one example would be to measure the liver temperature. Well, all things being considered, if we assume it's an average normal set of circumstances, then we can come up with a general rule that the body will cool down at a rate of about 1 to 1.5 degrees Fahrenheit per hour. And this will continue until the temperature of the body gets down to ambient temperature, and then obviously it will stop cooling down. In fact, it may even start to warm up, because after a few days, the heat generated by the process of putrefaction may actually cause the temperature to start increasing again. We'll talk about putrefaction in a short time. In addition to algor mortis, there's also the very well-known phenomenon of rigor mortis. Now, when you die, your brain stops sending signals to your body to do stuff, but that doesn't mean chemical activity in your body stops. And the cause of rigor mortis is the continuing chemical action in your muscles, and it causes them to stiffen soon after death. And then after further time, that stiffening disappears. It's a chemical action within the muscles. It doesn't happen uniformly over the whole body. It appears first, for instance, in the jaw, spreads to the arms and then to the legs. So it will be complete over the body in maybe 12 hours' time, and then it will gradually disappear again. Once again, this needs an experienced expert in the field to assess the state of rigor mortis of the body in order to give the estimate. A third method, not so well known, is livor mortis, also known by a number of other terms. Now, livor mortis is due to gravity. If you consider your blood consists of all sorts of materials, including the red blood cells, and it's maintained roughly homogeneous and in continuous motion during life by the action of the heart. On death, the heart stops, and then the effects of gravity start to be felt by the red cells, and they settle out to the lower parts of the body. If, for instance, the body is hanging by the neck, then the red cells will settle into the legs or the lower parts of the legs, and a distinct discoloration will be seen down there in the legs. Now, if the body is lying on the ground, it's not quite so simple. Obviously, the red cells will settle down towards the side of the body that is against the ground under the influence of gravity. You have the body temperature starting out at normal body temperature and dropping gradually to ambient, maybe going up again afterwards. You have the livor mortis and the rigor mortis appearing gradually up to reach their maximum, and then both fading away. And all of these require an estimate from an experienced expert. And of course, it's a problem. This relies on an expert giving his opinion. It's not a rigorous scientific method. So a lot of research has been done on trying to develop more scientific and hopefully more precise methods. One of the suggestions is to use ocular potassium, and that is the potassium that's present inside the eye, in the vitreous humor of the eye. The concentration of potassium in the eye is lower than the concentration of potassium in the rest of the body, and your biochemical machinery makes sure that this concentration differential is maintained during life. After death, that machinery is no longer operating, so potassium from the rest of the body will gradually diffuse into the eye, and the potassium content of the eye will gradually increase. And it's been suggested that this is a good way of measuring the time of death, relatively free from environmental factors. We can also use circumstantial evidence. Circumstantial evidence typically won't give you the time of death, but it gives you a time when that person was still alive. For instance, if at autopsy the stomach and intestine contents are examined, you can get an estimate of the time of the person's last meal. For instance, the stomach empties in about 2 hours. So if the stomach is empty, then you know it's at least 2 hours since that person had a meal. Technology is helping. You can look at someone's watch. Now, normally, of course, a watch will not stop when a person dies, but suppose this is a drowning case and it's a cheap watch. In that case, the water will cause the watch to stop, and you have a good timing of when the person went into the water. Mobile phones are very useful. If you think about it, what was the last time that you used your mobile phone? It wasn't very long ago, was it? So in the picture you see Dr. Nathaniel Carey, and this is a quotation from him. He said, "Nowadays, last use of the telephone can be terribly important." And he had been testifying in the trial of a man called Stephen Wright, who was convicted of the murder of several women in a short period of time just before Christmas 2006. And using the mobile phone records, they were able to estimate time of death. Because when you use your mobile phone, it shows you're still alive, and the time of that phone call is recorded by the telecoms company. And this is going to be an increasingly useful method.